Welcome to Lesson 2, a whole class session on prime factorization. Today, we are unlocking number DNA by representing composite numbers as products of their prime factors. Our learning goals are threefold. First, to distinguish between prime and composite numbers. Second, to use factor trees to find prime factors. And third, to express the final number as a product of primes. Let's review the building blocks. Prime numbers have exactly two factors, 1 and themselves. Composite numbers have more than two factors. Think of primes as the atoms of math. We will use the factor tree method. To find the prime factors of 24, we break it down. For instance, 24 equals 2 times 12. We circle the prime number 2 and continue breaking down the composite numbers. For step 1, collect all the circled prime numbers at the end of every branch. For 24, we found 2, 2, 2, and 3. Step 2, write them as a product. 2 times 2 times 2 times 3, or using exponents, 2 cubed times 3. Let's try together with 36. We can start with 6 times 6. Since 6 is not prime, we break each 6 down into 2 times 3. Remember, the starting factor pair does not change the final prime factors. Now for an independent challenge. Grab your notebook and find the prime factors for 18, 40, and 56. Check your work by multiplying the primes. Extra practice is available in the books listed. Here is the prime factorization quest. Write each composite number as a product of its prime factors for the challenges listed in red, yellow, and green. Here are the answers for the independent challenge. Review your work against these prime factorizations for the numbers in red, yellow, and green.